Right, okay, so we've got merge sort, my algorithm, okay, it works in 3 phases. So when you looked at merge sort at GCSE, you just looked at the general process and you were able to demonstrate it. You may get asked that at A-level as well, okay, but we need to understand what's actually going on in the logic. All right, so we've got these 3 broad phases. We have a split phase where we take a list and we try and split it down until we've got a load of lists with 1 item. Because that's one of our really amazing things, is that if we've got a list with 1 item in it, it must be sorted. And a lot of sort algorithms use that premise as their starting point. So if I can get down to single lists, I at least know I've got a starting point of sorted list. And then the problem is, oh, how do I put all these lists back together? So merge sort, as its name suggests, once it's done the split, does a merge phase where it pulls ordered data together and maintains order, basically. But merge sort is not an in-place sort. Every time we do a merge, we create a new list. And the final phase of merge sort is to copy the new list and overwrite the old list. All right, so that's that little bit at the bottom. Okay, you can, if you just tweak this a little bit, this pseudocode, you can turn it into C-based code quite easily. Okay, I've used post increments and things like that on it, which all C languages cover. Right, but let's just remind ourselves of the merge sort process first. So we've got a list, and this, if you're ever doing a merge sort, using square brackets to denote lists is probably the cleanest way of showing it. So what we do is we go into a split phase. So we start with a list with 4 items and we generate smaller lists. Okay, so we don't move anything, we just identify smaller lists. And that's the clever bit of the algorithm. Okay, so in the first split phase we end up with 2 lists, and then we eventually get down, kept this short on purpose, we eventually get down to single item lists. And at that point we say, right, we've got some sorted data. And then what we do is we take pairs of lists and we say, let's keep them in order and build a new list each time. So we take a pair and we go, right, let's make space. And if you think of it like this is how the algorithm works. It makes space to store 2 items. And it goes, right, okay, then starting in each list, which is the smaller one, so I'm doing ascending here. So we go, 14. And we say, right, well, there's no more in that list, so let's just copy the other list across. So we end up with a list that's in order. And then we move on to another pair. So it does it in levels. And again, we go, okay, let's have a look at these items. It doesn't know anything about these. We can see that these are all in certain orders, but the algorithm doesn't. So all we're doing there is say, right, of them 2, which is the smaller? Well, 12's smaller, isn't it? So we write the 12 down. There is nothing else in the list that 12 was from, so we can say, just copy the remainder of the other list. And we get to that state. So we've actually got 2 lists that are now ordered, both of them. And we can then say, right, well, let's merge these 2 together. And we'll make space first for 4 items. So make my empty list. And I'm just going to put markers at the start of both. And I'm going to say, which is the smaller? Well, I can see here 12 is. So I move the marker on in that one, and I compare items at the markers. 13 is smaller. I've exhausted that list. That means there are no more comparisons to make, which means I can quickly, and that's the essence of where merge sort beats a lot of other sorts, I can now quickly just copy the remainder of the other list. So I just go, yeah, 14, 15, done, sorted. Okay, so that's what this algorithm's going to do. Now, what we're going to attempt to do is trace it through. But because it's recursive, you have to keep track of local variables. Every time we call a function, we create a stack frame. And in that stack frame, all our variables are new. All right, and you'll see that in action. And it's really important that you do indenting when you're doing this. So that was the process. Let's have a look at the detail. Right, so we start with the same list and we're going to just literally go through this merge sort algorithm. So we're going to start by calling, oops, put my pen on. I'm going to call the merge sort. So I'm going to say merge and I'm going to pass the parameters. So it's the list, which I'm just calling li. You'll notice that I don't do anything with the list other than just pass it. So I'm passing the location, the memory address of the list. And then I've got the bottom of the list. So initially I'm going to sort from 0 to 3. So the entire contents of the list. Now what's really important is that we now set up the values of the parameters. So you can see I've got a value for a parameter called b, so that is going to be equal to 0. A value for a parameter t, that's going to be equal to 3. This is important because we'll need to look back at these. Now the first line of the calculations that are in there are where we calculate mid, which we're just shortening to m. I've just made a typo there. And we do a calculation. And we say, like, t plus b, so let's have a look. T is 3, b is 0. Add them together, divide by 2. Now that is div 2, so that's integer division. So m will be 1. Everyone happy with that? Okay. Then we've got an if on line 6. And it says if m is greater than b, which is true, m is greater than b, then we've actually identified that there is a sublist. So we're actually going to call merge sort again. Now, what's actually important is that we keep track of where, when merge sort finishes, we end up. So we're going to write merge and we're going to put our parameters in. So it's going to be li again. But this time the parameters are b. So let's just look up the local b, which is 0. And it is m. So m is 1. So we call it with that. Now, when this finishes, the next line we're going to execute is what? What number? What is the line that is after this function call in the algorithm? So I'm doing this one. What's the line that will be executed next? Line what? 8. If I'm executing line 7, the next line is 8. So I'm going to just make a note of that because I'm going to be doing loads of work and then I'm going to want to come back and I don't want to have to look at anything. So I'm going to mention that. Return to line 8. Going to set my parameters, say what values the parameters were at. So I'm going to say b equals 0 and t in this case equals 1. So immediately you can see this is not the same values of b and t that we had before. We're indented, we're in a stack frame. This is local data. Right, I'm going to calculate m because that's the first line of the code. So it says add them together and divide by 2. Well, 1 div 2 is actually 0. Okay? So 2 doesn't actually go into 1 at all. It goes in 0 times. Right, then I get onto this if section again. It says if m is greater than b. Well, no, m isn't greater than b, so I'm not going to do that if bit. Move on to the next if. It says if m plus 1, so I'll look back to see what my value of m is, so that's going to be 1. If that's less than t, 1 is not less than t, is it? So I'm not going to do any more recursion at this point. So I'm going to move on to this next phase, this merge. So basically what I've said is I've got down to single lists. I've identified 2 lists here. Okay, they've got items that need merging. Right, so I've got to set some variables up. Now to keep this compact, I'm going to do this on one line, but you've got to be careful because these values are going to change. So it says L equals B. So I look back into my stack frame and see that B is 0. I'm going to leave a little bit of a space to do R. It says R is M plus 1. So again, I look on my current stack frame and I can see M is 0. So that's 0 plus 1. So R must be equal to 1. And then I've got this other value S. This is just going to be a pointer to the new list I'm making. So I'm just leaving a gap. I'm just going to set S to 0. Okay. Then I create an array. So this is the bit where merge sort is making some new space up. So I'm just going to draw my array and it's got a size. It says t minus b, so t is 1, subtract 0, and that's 1, plus 1. So it has to hold 2 items. So just in when I was doing the algorithm, oh, I've got 2 things to merge, I need space for 2 items. So I'm going to write my new list like this. And I'm just going to put the indexes on 0 and 1. Okay, because it's a new list. Then I go into this hideous looking while loop. But actually this is simple. All I'm doing is I'm doing the merge process now. So I'm just going to check if L is less than or equal to M. So let's look at that. 0 is less than or equal to M. So that's true. But for this loop to continue, R has also got to be, and R is 1, less than or equal to T. Yes, that's true as well. 1 is less than or equal to T. So this while loop's going to happen. So we just do a comparison, and you can see what we're doing here is saying which one's the smaller then. At the left and right pointers, which one's the smaller. So we say, right, if the item at L is less than the item at R, so L is 0, so look at your list, that's 15. R is 1, well that's got a 4, so 4 is smaller. So that's not true, so we're going to do this else bit. So we're actually going to copy to the position in our new array at S, the value from the right pointer, which is a 4. And then we're going to increase that. And we're going to increase the S. That's what the plus plus means. It means afterwards. It's what post increment we call it. Okay, so we've put the 4 in there. We're going to go back round to the while loop and we're going to see if the condition's still true. Right, so 0 is still less than or equal to 0. But this time, R is 2. That's not less than or equal to 1. So the while loop is finished. So what we've essentially said there is we've exhausted one of the lists. So now what we're going to do is copy the other one. Obviously we've only got one item here, so it's not going to take much work, but you'll see this later on. Okay, so we get down to this if, and we're just checking which list are we copying, the left one or the right one. So we say, is L less than or equal to M? Yes, that's true. So it is the left-hand list, okay, that we are going to copy over. So it just says, right, copy, and we got a while loop that says just copy the entire list is the effect of this. So it says, right, at S, which is 1, will you place whatever's at the left pointer? So the left pointer is 0, that's a 15, so let's whack a 15 there. Let's increase S, and let's increase left. Okay. Right, the while loop was controlled by saying is left less than or equal to M. Now that's not true anymore, so the while loop stopped. And you can see we've filled this new list up. And they're in order, they've merged properly. So we're going to go drop down and we're going to do this copy process. So we're going to say, let's set these 2 variables up. T is equivalent or is set to the value of B. So I look in my stack frame, I can see B is 0. F always becomes 0. So let's just do them on the same line with a little bit of a gap. And then we've got a while loop. This is just going to do a copy. So basically what we're doing is we're copying this new list and we're overwriting a portion of the original list. So it says at the list pointed to by T, which is currently 0, will you copy from the new list wherever F is pointing? So we're going to copy the 4. So we're going to cross that out and put a 4. And then we're going to increase T and we're going to increase F. Now we will keep doing this until F becomes bigger than S. So, oh, I'll put an S there, not 2. Idiot. I don't know why I did that. Right, so that's 2. So S is currently 2. So 1 is less than 2. So we're going to do the loop again. And we can see we've got to because we've got 2 items here to copy. So we're going to copy to position 1 here from position 1 in the new list. So we're going to put our 15. So you can see I've now copied back my list. And I've finished. My while loop is now over because 2 is no longer less than 2. So I've done my full copy. So I'm now going to go back. So I'm going to return to the previous call frame. I wrote at the start of this bit, return to line 8. So I know where I'm going to. So I'm actually returning. I'm just going to put a little symbol for myself at 8. Just so I'm telling myself, you're on line 8 now. You were in the middle of a previous run of this function. Right, so I'm going to pick up at line 8. Well, we got an if, and it says if m plus 1. Now we've got to look for the stack frame we're in. We're on this stack frame, so this is all gone now. This was all destroyed when we came out of the procedure. This is the stack frame, so these are the values that we're looking at. So we say m is 1. Right, m plus 1, so that's 2. Is that less than 3? Yes. So we're going to call the merge sort again. So we're doing the other half of the list, basically. So we're going to say merge. And we've got a little bit of calculation to do here. So we're going to pass it the list. And it says m plus 1. So again, look at the level. The indentation is critical here. The level that we're looking for this stack frame is here. So it's m is 1. So I've got to add 1 to that. So I'm going to pass a 2. And I'm also going to pass whatever the current value of t is in this stack frame. So t is 3. So you can see I'm now going to do a merge on the other half of the list. Right, okay, so I'm trying to make this as uncomplicated as possible, but there's a little bit of complexity to this algorithm. So when we finished this function call, we're going to return, well, technically it's line 10, but actually the first bit of code is on line 13. So I'm going to say return, because I've put some comment in there, to line 13. So when I finish this call, I'm going to carry on with the rest of the program from that point. So again, I'm going to start off and I'm going to set up my parameters so that I've got a record of them. And this is my new stack frame now, so these are all new and local. So b is 2, t equals 3. Okay, so I'm right back up here now. So I'm going to calculate m. So m is t plus b, oh god, 5 div 2. So 5 div 2, integer division should be 2. Yeah, 2 goes into 5 twice. Right, we then look at our ifs. So we say, right, is m, so 2, is it bigger than 2? No. So I don't need to do any more splitting. Let's have a look at the other if. M plus 1, so that's 3. Is that less than 3? No. So I don't have any splitting to do. So I'm going to carry on with line 13, where I do the merge process. So we've got down to single lists, single item lists. So we're going to go L equals B. B in this stack frame is 2. Leave some space. R is M plus 1. So that's 2 in the stack frame plus 1, so that makes it 3. So we're saying, right, the left-hand part of this sublist is at 2, the right-hand part is at 3. And that makes sense because we know these are single item lists. Right, and then we calculate S, and again, S just starts at 0 because we're going to create a new list, and that's the pointer for the new list. Right, so let's make that new local list. It's got to be enough space based on this little formula. So t minus b, so that's 3 minus 2 plus 1. So that's 2 items. So I'm going to have space for 2 items. Okay, right, so let's do the merge process. So we go into the while loop and we say, right, while L is less than or equal to M, that's true. So 2 is less than or equal to. And while R is less than or equal to T. Well, that's true, because that's 3. 3 is less than or equal to T. So we're just saying, like, just as soon as one of them gets to the end of its list, stop this while loop. Stop doing this complex comparison and merge. Right, so we're going to make a decision. We're going to say, right, okay, the item at left, and left is 2, so that's 12. Is that less than the item that's at the right pointer? Well, the right pointer is 3, that's a 13. Yeah, that's okay. So it's the left-hand one, so we're going to execute this bit. The left-hand one needs copying, so we're going to put the 12 in the new list at position S. Then we're going to increase S, and we're going to increase L. Hopefully that's going to stop our merge process, but let's just check. So we go back up to the while loop condition, and we say, right, is L less than or equal to M? 3 is not less than or equal to M. So that while loop stops. And we drop down to line 22. And we say, right, okay, so which list have we got to just copy over now? Which one can we just dump? So we say, right, L is less than or equal to M. No, that's not true. So it isn't the left list. We've done that one. It's the right-hand half. So it's this bit. So we go into this bit of code for this while loop that says, like, copy the right-hand list now, will you? So R is less than or equal to 2. Yes, that's still true. R is 3, T is 3. That is true. So we're going to copy to position 1, that's what S is saying, in the new list, from the R position in the original list. So that's going to put the 13 in there. R increases, S increases. That while loop is no longer true. R is not less than or equal to 3, because 4 is bigger. So we go back to this final phase, copying and overwriting the original list. So we're going to set up T. So T is equal to B. So it's the B of our current stack frame. So that's 2. F is going to be 0 again, because it always says, right, okay, you've got your new list, F's pointing to the new list. Right, and we just need to copy over. So we're going to say, right, copy from the new list at position 0 to the original list at T, which is 2. So we're going to put something here. So we're going to copy from position 0 in the new list. And actually, we are overwriting, but we're overwriting with the same number. We don't examine it, we're just obliterating. So we increase T and we increase F. The while loop is still true, so we're going to do another copy. And we just say, right, copy to position 3 in the list from position 1 of the new one. So we're going to copy the 13. And that's the end of that. So we've merged and we return. So we do our return and we say, oh, cleverly, we said return to 13. That's where I'm going to carry on. So I've actually now got 2 lists, 4 and 15, they're in order, 12 and 13, they're in order. We're now dropping back to our original call of merge. So this data values of this stack frame are what's going to matter. So we're at line 13, so we're actually going to do a merge. We've basically said we've got 2 sublists. So let's have a see how this all works out. So we've got to do these setting of these initial merge variables. So the left pointer is equal to B. So let's have a look. So you've got to ignore all this stuff, and we're going right up here, and we're going to say, right, this is the stack frame we're in, B is 0. Leave a bit of space, leave a bit more space this time. Right is M plus 1. So in this stack frame, M is 1. So the right pointer is going to be 2. So you can see the left pointer is saying, the first 2 items. The right pointer is going to be pointing at the next 2 items. Right, so S is going to be 0, because that's what it says. We're going to create an array. So I'm just going to scroll up. I don't need to look, well, I need to keep that in mind. Right, so I'm going to create my new array, my local array. Right, it's got to have space, and it's B minus T. So let's have a look. B in this stack frame is 0. T is 3. So that's going to be 3, and we're going to add 1. So we need space for 4 items. So we're going to say 0, 1, 2, 3. And remember, that's what S is telling us where to write in this new array. Okay, so we're going to do the merge process. And, just need to be able to see just can see the array. Right, okay, so I can't see it. Let me just zoom out a little bit. That's it. Right, okay, so the while loop says, carry on doing this loop if those 2 conditions are true. So as long as left, which is currently 0, as long as that is less than M. Now M is right up here, massively far up. So you've got 2 options here. You could, if you wanted to, just duplicate M, B and T, if that's what you want to do, or just be careful and make sure you look at the correct values. Don't look at these values, they've gone. They died when we returned, when we ended the procedure. Okay, so we're in this stack frame. So we're saying as long as left is less than or equal to m, and that's true. The loop can happen. The other condition was the right pointer, as long as that's less than the top. So right is 2, t is 3. So that's true. So we're going to do a merge. So we're going to say, right, compare the two values at the pointers. So the left pointer is here, 4. The right pointer is pointing to 12. Which is the smaller? Well, it's the left one, isn't it? So the left one gets copied. We then increase s. We then increase the left pointer. We go back round and we say, is this still valid? So the merge process is really simple. You're just saying, compare two values, which is the smaller, copy the smaller, move the pointer on in that list. Right, so left is now 1. That is less than or equal to the current value of m, which is 1. So the loop's going to change. R hasn't changed, so that part of the equation we don't even need to consider. And we say again, right, okay, which is the smaller, the one at the left pointer or the one at the right? So at position 1 we got 15, that looks big. The one at right, which is 2, is 12. So we're going to copy the 12 this time. And we're going to move the right pointer along, and we're going to move the S pointer along. Okay, so the S is ready to fill in the next one. Okay, going back to our while loop, we can see that R is still less than or equal to T. So 3 is less than or equal to T, and so is L. L is less than or equal to M. So the loop's going to happen again. So we're going to do another comparison. So we can say, right, the left point is pointing to 15. The right point is pointing to 13, which is smaller. Well, 13. So I'm going to write 13 down at the value where S is pointing to. Right, R moves on to 4, S moves on to 3. So S is ready for the next value in this merge. R is indicating to us, to the algorithm, that, yeah, we've exhausted the right-hand side. So actually, you've done on that list. So this while loop will no longer continue because R is no longer less than or equal to T. Okay, so we're going to drop through to see which half of the list we need to now just copy over. So we look at this, we say, right, left, is it less than or equal to M? So looking at left, left is 1, that is less than or equal to M. So it's the left-hand list that we need to complete now. The right-hand one's exhausted, we knew that, but the algorithm needed to check. So we're going to do this bit. So we're going to say, copy where the left point is pointing to. So the left point is pointing at 1, which is a 15. So we're going to copy that. We're going to increase S, and we're going to increase the left pointer. Now, that stops this copy process happening because left is now no longer less than or equal to M. M is 1, remember, in this stack frame. So we've finished the copy process, the merge. The merge is over. What we've now got to do, we have got a list here that we need to overwrite the original with. So we're going to do this final process. So we're going to set up T. So T equals the value of B. So looking back at my stack frame, I can see B is 0. F is going to be 0 because F's referring to the new list. Always referring to the new list. And all we're going to do is we're going to do this copy. So we're going to copy from the new list at position F to the old list at position T. So we're going to go, and this is a bit silly. I wish I could move those pens off the screen. So I'm going to overwrite the 4. And it's important to know that this is what's happening. Okay, so the 4 gets overwritten. And then we move these 2 pointers on. Then we're going to copy the item 12. And then we're going to move these 2 pointers on. So T is where we're writing to. F is where we're writing from the new list. So now, position 2 from the new list is 13. That's got to go to position 2 in the original list. Increase the 2 pointers. So then we're going to get the 15 from the new list and overwrite there. Okay, and that's the end of that while loop. It's going to end, and then the process ends, and we just carry on with wherever we called the merge sort originally. We have finished the merge sort. The original list is now super magically sorted. There is the list. 4, 12, 13, 15. Yes, Colin? Do we have to do this? No. But ages and ages ago I said one of the things we need to look at is recursion. This is a great example of recursion. It's a complicated one, okay, but it introduces lots of concepts which we'll drill down on and reinforce to do with the stack frame, okay? Because you've got loads of values going on here, but none of them are relevant apart from the ones that exist locally to you. Right, I'm going to stop the vid there.